In this video, we are going to look at evaluating powers and radicals without using a calculator. A lot of what we're going to look at is using the factor tree, breaking down our bases so that we can look at the exponents. Please keep in mind we're going to do a lot of fractional work in this video, and we're also going to look at a lot of negativities. So to begin with, I'm going to break down 64. So what number goes into 64? 8 and 8 works. You could have done 2 and 32. It doesn't matter. 8 breaks down into 2 and 4, and then 2 and 2, getting those prime numbers. So again, 2 and 4, 2 and 2. So 64 is written as 2 to the 6th. Now you might be thinking, why in the world are we doing this? Well, let's take a look at what the problem states. It says 64 to the 7/6. Now keep in mind our exponent properties. There's a fractional exponent, which means the numerator is my exponent, the denominator is my root. So I don't want to do 64 times itself 7 times and then take the 6th root of it if I'm going to do this without a calculator. So to begin with, I'm going to break down 64 with its root. So I need to take 64 to the 6th root. Now, you may know what it is. If you don't, it's very helpful to do this factor tree. So I can rewrite 64 instead as 2 to the 6th. And then it goes to the 7/6. Okay. And then I know what to do when I do power to a power. I have an exponent and then another exponent attached. So again, looking at those exponent properties, I multiply. So 6 over 1 times 7 over 6. So 6's cancel. It's 2 to the 7th. Now you may look at 2 to the 7th and go, I don't know what that is. But you know 2 to the 6th already. I need one more 2. I need to double it one more time. So 2 to the 7th, without your calculator done, is 128. All of this done without our calculator. So this is just one example of breaking down without using your calculator. If you get stuck, do the factor tree, rewrite it out. Next example. Now I have the quantity negative 64 to the 2/3. Now I have a negative base. That negative does go to the 2/3 power because the 2/3 is on the outside of my parentheses. So now I have to look at and go, okay, first off, can I even do this problem? Then, is it positive or negative? So kind of those two steps to go through. First, is it possible? Second, is it positive or negative? The bottom number, remember, is your root. So I'm looking at the cubed root of negative 64. So I need a number times itself 3 times to give me a negative 64. Is it possible to get a negative when I take a number and multiply it by itself 3 times? Yeah, it is. I can do it. So I can do this problem. Now I have to look at, is it positive or negative? I'm taking it to the second. I'm squaring it. Is that result going to be positive or negative? And hopefully you said positive. So this is going to be a positive result. So now I can get rid of that negative, and all I'm looking at is 64 to the 2/3. Now I'm using 64 again because we already did the factor tree. Save you a little bit of time. I know 64 is 2 to the 6th. Now, do you know what the cubed root of 64 is? If you do, wonderful, you can break it down further. However, you are bound to find a time where you don't, or it doesn't actually end up perfectly that way. So power to power, I multiply. Again, that process is 6 over 1 times 2 over 3. 3 goes into 3 once. 3 goes into 6 twice. So 2 times 2 is 4. So this is 2 to the 4th. 2 to the 4th, hopefully you know, is 16. So if you have a negative base, first you look at, can you do it? Second, you look at, is it positive or negative? So here's another situation that's similar. Oh, I'll close up the second one. So I have negative 64 to the 3/2. First off, look at your root. What's the root? Square root. A number times itself twice. Can I get a negative out of it? Nope, no real solution. We will not look at imaginaries here. Oh, no real solution, sorry. So you can write this and be sufficient. Next one differs. It looks very similar. However, the negative is no longer the base. 64 is my base. It's the opposite of 64 to the 3/2. So I know in the end, my result is going to be negative. Because it's the opposite of whatever that result is. That's what the negative sign means. It's the opposite. So rewriting 64 just like before. 2 to the 6th to the 3/2, power to power and multiply. So 6 over 1 times 3 over 2 gives me 2 to the ninth. And I know it's negative. And 2 to the ninth is just 512. Okay, so that's breaking down having that base negative. How do I work with it? Can I? Is it positive or negative? Now the negative is my exponent. A little bit different. This one, in my opinion, is easier to deal with than if my base is negative. Because I know if I have a negative exponent, that's that elevator button, it takes the base and the exponent and pushes it. So if it was in the numerator, which is it is here, it pushes to the denominator. If it's in the denominator, it pushes to the numerator. So that negative exponent is just like saying 64 to the 3/2 power. 1 over that. Because it takes a negative exponent and pushes its location. So now I just rewrite my 64. 1 over 2 to the 6th, all to the 3/2. Power to a power we multiply like we did before, which gives me 1 over 2 to the 9th, which therefore is just 1 over 512. So negative exponent has its own different rule to work with. So keep in mind, if you have a negative exponent, you're not sure what to do, move it to where it appropriately goes. And hopefully from there, you can start looking at some other different ways of simplifying your processes down. Here's another example, different numbers, different shapes. This is another case where I'd be looking at breaking it down using the factor tree. So I can just take a look and see what's taking place. So take a moment, please. Pause this for a moment and do your factor tree for 81 and 729. So 81 is 9 and 9, 9 is 3 and 3, 9 is 3 and 3. So 81 is 3 to the 4th. 729, start looking through, okay, what number evenly goes in there? I'm going to try a 3 because it ends in an odd number. Now, I don't know if you know the trick about 3s, but 729 is divisible by 3 if, when you add up each of the individual numbers, it is divisible by 3. So I take 7 and 2 and 9, and I add those up, and I get 18. And then I take 18, and is it divisible by 3? Yes, it is. So I know 729 is divisible by 3. So now go through, do the long division into it. 3 goes into 7 twice, with 1 left over. 3 goes into 12, therefore 4 times, and 3 goes into 9 3 times. Break that down. I can see 3 goes in there. 3 goes into 24 8 times. 3 goes into 3 once. Hey, 81, I've done that already. 9 and 9, 3, 3, 3, 3. So 1, 2, 3, 4, 5, 6. So 3 to the 6th is 729. Okay, all that work done. Why would I do that? Well, because I don't know what the cubed root of 81 is, and I don't know what the fifth root of 729 is. But I do know that 81 is 3 to the 4th, and I do know 729 is 3 to the 6th. And then they also have those roots. First thing I'm going to do is rewrite this, or next thing I should say, 81 to the 1/3. Divided by, get rid of that division sign, write it as a fraction. 729 to the 1/5. I know 81 is 3 to the 4th. So now that I have it written exponentially instead of radically, I can rewrite, instead of 81, that's 3 to the 4th, all to the 1/3. Over 729, we figured out is 3 to the 6th, and that's all to the 1/5. Now, yes, it's still ugly, but you should see some commonalities. They both have the same basis. So, exponent properties, power to power. 4 times 1/3 is 4/3. Over 3 6 to the 1/5 is 6/5. Bases are the same, so I subtract those exponents off to the side here. 4/3 minus 6/5. Get that common denominator when you subtract, remember. So my common denominator is going to be 15. So 3 times 5. So multiply the 4 times 5, which gives you 20. And then this one needs a 3 to get that denominator to be 15. So I also have to multiply the top by 3. So that denominator is 15. My numerator, subtract, is 2. Since bases are the same, I subtract exponents and I rewrite the base. So it's 3 to the 2/15 power. So that's my answer to this. Started out kind of ugly. The process kind of looks ugly. But eventually, it's not too bad. It's the 15th root of 3, which I don't know what that is. I don't know how else to simplify that. And then it's squared. If I really wanted to write that out, it could be 9 to the 1/15th. But we are writing it exponentially, so this is sufficient. Okay, next example. I'm going to show you two ways to go through this. First off, I want you to pause it at this point in time, and I want you to try something. Without physically looking at what I'm going to do, I want you to think of something that mathematically you can do to this problem, no matter what it is. So pause it just for a moment, and then I'll show you two different ways I would go about it. Not that they're the only ways, but I'll show you what the answer should be to see if you got yours right. We can talk about if you got it wrong tomorrow in class. So there's something that I see right away. I have power to power, so I think of multiplying. So I have 36 to the 1/3 to the 1/2. Well, that's just 36 to the 1/6. Okay, so far so good? Power to power, I know I can multiply. Again, it's an option. It's something I can try to see if it breaks down nicely for me. So now 36, I don't know what the 6th root of 36 is, so I'm going to break it down. It's 6 and 6, 6 is 2 and 3, 6 is 2 and 3, so it's 2 squared and 3 squared. Okay, that's what 36 is. So substitute that in. 2 squared times 3 squared, all to the 1/6. Now I have a product with an exponent, and they all have exponents as well, so I send that 1/6 to each of them. So it's 2 to the 2/6, which you know is 1/3, times 3 to the 2/6, which is 1/3. And that simplifies. Now, we have to go backwards properties for a moment. You guys learned the following property. A times B to the n, for instance, is A to the n times B to the n. And I got to be able to go backwards, too. So if I have two quantities taken to the same exponent, I can pull out that exponent and physically multiply the bases. That gives me 6 to the 1/3. That is my simplified answer, 6 to the 1/3. Now again, that's one way to do it. A couple other things you probably could have done along the way. There's one more way that I see that's a little bit easier, a little bit quicker. But again, you're going to get the same answer. It just might take you a step or two longer. Now keep in mind, power to a power you multiply. So I'm multiplying 1/3 times 1/2. Does it matter which order I multiply by? Can I take 1/3 and multiply it by a half? Or can I take 1/2 and multiply it by a third? Does it matter? Okay, so what I'm going to do is I'm going to rewrite this. It's 36 to the 1/2 to the 1/3. What's 36 to the 1/2? Remember, the bottom one is your root. It's the square root. What's the square root of 36? 6 to the 1/3. And that's the same answer that we got before. Less work, but you had to see it first. So it depends on what you see as to the process you go through when you're trying to simplify these. Just because I do it one way is not the only way to go through them. My tip, my recommendation for you is check your negativity. Check to see where it falls. Anytime your negativity is your exponent, if you don't know what else to do, push it. If it's in the numerator, push it to the denominator. If it's in the denominator, push it up to the numerator and give it that positive negativity. That is the one thing that I see quite often mistakes made on, is that negative exponent only moves its location. It has no bearing on whether the problem is positive or negative.